So I told you we're going to take lines of best fit a step further. So we're going back to the equation of a line, way back chapter 3. Does anybody remember slope-intercept form? Y equals, very good, mx plus b. What did m stand for? Slope. And b stood for your y-intercept. Now here's the situation. We got to remember a few of these things, okay? So here's example 1. And this is where people get confused a little bit. I'm going to reiterate to you. Everything is about the line. Once the line is drawn, ignore the points, okay? Ignore the points. They mean nothing to us. Using the food drag graph, how do we find the slope of this line? How do you rise over run? What else? How am I going to find the slope of this line? You're right, slope is rise over run. Yeah, we got to find 2 points, right? Remember we had the 2 points? Okay, this is where it's crucial. Ignore the points. You're only looking at the line. You're only looking at the line. What are 2 points on the line, not the actual data points, that would be good for us to use for slope? I would not. Look at 40, 15. See how that looks like almost a perfect point there? Gable, you got another one? 80, yeah, I like that one. Notice, were those exact data points? No, they're on the line. Okay, so 40, 15, 80, 30. Now what do I do with 2 points? Okay, which one goes on top? Which letter goes on top? Y on top. Y on top. Okay, so give me a Y to start with. Say it again. 30 minus 15 divided by 80 minus 40. 30 minus 15. 80 minus 40. 40. Now here's the best thing ever. When we were doing this before, we had to use a fraction. Lines of best fit are approximations. So today you get to use a decimal. So take 15 divided by 40. Always round to the nearest hundredth. 38. 0.38 is my slope. Now, how do we find a y-intercept? I would love to just look at it and say, oh, here's the y-intercept. Well, we all know we can't do that, right? Remember, this is where we used our slope and a point, and we plugged it into point slope. Okay? So we know our slope is 0.38. Which point do you want to use? 40, 15 or 80, 30? 40, 15. Okay, do you remember point slope? Y minus y1 equals m parenthesis x minus x1. This has been a long time since we've done this. Okay, so we have to replace 3 things. The y1, the m, and the x1. Y minus 15 equals 0.38 parenthesis x minus 40. Now what do I do? Very good. Distribute your 0.38. So y minus 15 equals 0.38x negative 15.2. Okay. And my last step. I want to get y by itself. So how would I get y by itself? Add 15. Y equals 0.38x minus 0.2. So what is the y-intercept technically? Very good. Negative 0.2 is my y-intercept. And actually that process gives me, it says, what is the equation of the line? That gives me the equation of the line. So even though we're trying to find our y-intercept, it actually solves it for us. Now I always double check this. If I continued this, does that seem pretty accurate to be just below 0? Yeah. I would say absolutely. If you calculated this and you got like a 7 there, ding, 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 I screwed something up there, right? I screwed something up. Okay? This process is going to be repeated over and over today. Okay? I've been even impressed with what you guys knew there. Oh, wait, we got to interpret it. What does the slope mean? Now remember, our slope was 0.38 technically over 1. Which letter went on top? Y. What's our label for Y? Tons of food, right? 1. So every one volunteer, they collect. Now be careful. Volunteer, they collect. We're going to keep a label in there, right? 0.38 tons of food. I think your interpretation will be fine as long as you remember to go back and put those labels on there, right? Writing that sentence is pretty easy. What's my y-intercept interpretation? What does your y-intercept mean? Say it. It's your starting point. Does it seem kind of weird here? With a negative? But technically that's what it says. So they started with negative 0.2 tons of food. Now remember, this is the line of best fit. So does it mean that it's 100% accurate? No. How much did they really start with? 0, right? They started with 0. But you're interpreting according to what your plan is. Well done, Manny, though. Your slope is how they change. Your y-intercept is where it started. So today we're going to have that line, but then we're going to talk about, based on the conjectures and everything like that, what does it look like? What are my calculations? So we're going to do the same thing all over again. Write an equation in slope-intercept form for the line drawn that approximates the data, then interpret the slope and y-intercept. So the very first thing I have to figure out, my slope. In order to calculate my slope, I need 2 points. Now, on the line, not necessarily data points, on the line, I always go through and say, are there any perfect points on this? Where do you think? 2, 6? I do like 2, 6. Where else? 4, 1? Love it. 2, 6, 4, 1. On your own, calculate the slope. Round it to the nearest hundredth. As a decimal, what do you end up with? Negative 2.5. Does it make sense that my slope is negative? Yes. It's going down as I work my way towards Hoosier, right? It's going down. Okay, so then part 2 is the equation. For the equation, I need a point. Which point would you like to use? 2, 6. And you need your slope, which we just figured out was negative 2.5. So we fill it into y minus y1 equals m times x minus x1. Y minus 6 equals negative 2.5 times x minus 2. My next step, distribute here. Y minus 6 equals negative 2.5x Say it again. Plus 5. Very good there. Plus 5 because a negative times a negative. Nicely done. And then my next step or last step, add 6. Add 6. My final equation, y equals. Look at your graph. Seem pretty accurate? Absolutely, okay. Box that in because that's my final answer. Now I need to interpret both my slope and my y-intercept. Anybody want to take one? So this is piano practice. Say it again. So put our labels on here, right? Negative 2.5 over 1. Now, careful. You're close. For every hour more you practice, there'll be 2.5 less mistakes. For every 1 hour of practice, the number of mistakes goes down by 2.5. You don't really want to know, right? How do I interpret my y-intercept? When they started, they had 11 mistakes. Yep. Bless you. Is it? How long is the piece? I don't know either. You probably just jinxed me. Okay, let's flip this over. I'm going to skip this top got it one. Let's go right here. You can use an equation that closely fits a set of data to make a prediction about the data. Before, when the line of best fit was drawn, we approximated by just coming up on the graph and checking it. Well, if they provide us an equation, this gets a lot easier. The scatter plot shows the number of text messages that are sent and received in a month by different people and their age. The equation y equals negative 80x plus 4,500 can be used to approximate the data. Let's predict how many text messages a person who is 55 years old will send and receive. Well, if we look at this, 55 is not on our graph. See that? Okay? But age is our x value. So if we take our equation and we plug in 55 in place of x, so negative 80, and then I'm going to plug in 55, and then it says plus 4,500. Order of operation says, what do you do first? Yeah, you multiply your negative 80 and 55, and you get 4,400. Then I have plus 4,500, which gives me 100, right? What would my label be? Text messages or texts. So they predict that somebody who's 55 will send and receive 100 texts. I would argue that. My mom's over 55 and she sent way more than that. I don't know.
I don't know. It depends on the person. Yeah.
Okay. Top or bottom? Example 4. Okay, we'll do example 4. I heard top twice. The scatter plot shows the amount of money a company spends on advertising and the amount of money they make in sales over several months. Write an equation for the line of fit drawn. Then use it to make a conjecture about the amount of money the company will make in sales if they spend $60,000 on advertising. Number 1 is that we have to write an equation for this. You guys walk me through this. In order to write an equation, what's the first thing I need? Slope. In order to calculate slope, what do I need? 2 points. What do you got for points? I would say 5, 250, absolutely. Four 450, 40 450, or 5,500. I think 50 comma 500 is even closer, right? Now, if you used 40 comma 450, I'd probably still be okay. It's very, very close there. On your own, find your slope. Which letter goes on top? Y on top. Y on top. I get 250 over 45. Is that what you got? Okay, which ends up as what as a decimal? 5, 6? Question.
How did we get the point to
50, 500. It's on the line. You don't pick data points. You do not pick data points. You ignore the data points once the line is drawn there. You're just basing it on just that line. Good question, though. Okay? So now my next step, I got to write the equation part. What do I need to write the equation? My slope is 5.56. And which point do you want to use? 5, 250. All right. You guys plug it in. See what you get. Now check me. I got y equals 5.56x plus 222.2.
Yeah.
And if you look up here, does that match pretty close to what you think your y-intercept is? I always use that as a nice check. Between 200 and 250? Yes. Okay? Now it says use your equation. So we got to use our equation to make the conjecture. How am I going to determine this conjecture? What am I doing here? What does it ask you to do here?
Is it asking you to make a statement about it?
Oh, read your directions. Gable?
sell, or if you have 60,000, 60,000
How do you know if you put it in for x? See where he's talking about up here? If they spend 60,000 on advertising, is X or Y on advertising? X. So take your equation, you're absolutely right. Take your equation and plug in 60,000 for X. Y equals 5.56. I'm going to plug in 60,000 plus 222.2. Watch your zeros here. Watch your zeros, right? 60,000, that'd be 4 zeros. I got 3,33600. $333,822.20. Oh, pause. Wrong. Why is it wrong? Yeah, this says in thousands of dollars. So I shouldn't have plugged in 60,000. I should have only plugged in 60. I was like, gosh, this number seems really big. Told you, Maya, you jinxed me. 333.6 plus 222.2. So 555. Whoops. Come on. Bless you. 555.8. What label should I have here? Dollars, but also something else. Thousands, right? So if you wanted to, you could move your decimal over as well. Okay, one more. Flip it over. Example 5. The scatter plot shows the number of hours different people trained for a 5K race and their time. How much faster is the 5K race time expected to be for a person who trains 35 hours as opposed to 12 hours? So they break it down for us. It says, what is the task? Well, what is the race time for somebody who trains 35 hours? What would you guess? 15 or 16, right? 35. I wouldn't say 15. 16? 16 minutes. What is the race time for somebody who trains 12 hours? Now, do we want to use 12:35? It's not on your line, right? So 12, you know about where it is. What would you really say? 12:34? So 34 minutes. How much faster is one than the other? How would you calculate that? Yep, 34 minus 16 would give me 18. 18 minutes faster. 18 minutes faster. That is very fast. Can I run it? I can run it in 34 minutes. I cannot run it in 16. Okay. Your homework is only 9 questions, so it's not crazy long. But I will tell you, I'm not sure if you can all fit your work on here. Okay? So if you do not have enough space, don't cram it. Feel free to either grab grid paper or another sheet of paper, and then we'll just staple it to this. You're going to keep it if you get it done in class. I don't think you're going to get it done in class anyway. We have 9 problems for tomorrow's homework. It's really for